The goal of this video is to demonstrate how the mesh can help achieve HA or failover for between two zones when you have the same microservices deployed on one hand and on the other end. So in this particular case, I have 4 applications running on each cluster, right? And also I have Kong gateways deployed and also clients that will be part of the mesh. If we zoom in a little bit on this architecture, what you can see is the mesh that is spanning all the microservices and the gateways, and also a couple of additional components like the mesh zonal control plane on each zone or cluster, and also a global control plane for Kong gateway and a global control plane for Kong mesh, right? Now with that, what I'll demonstrate is under normal circumstances that the traffic can flow in the north-south direction and also in the east-west direction, starting from client 1 to application A, for instance. So let's go with the normal case. In this case, I'm hitting gateway 1, which is this gateway, and I am also using that path / app A, which stands for this particular application A. So what we can do with this command, if that works, yeah, what we can see is that application A is responding, and this is application A that is running on cluster 1, which is what we wanted because we're hitting the gateway on cluster 1. So now if we do the same with gateway running on cluster 2, my expectation is that application A on cluster 2 will answer, which is what's happening now. I'll now do the same test for east-west communication. So basically I start from client 1 that is running on cluster 1. If we look at this schema, right? And again, my expectation is that when I do hit the Kubernetes service name application A or application A.demo, which is the namespace name .svc and the port name or port number, I get an answer from the local application A, right? So that works well. Now let's enter the mesh. So what we want is to achieve HA and global failover. What we want is to better configure our applications when it's calling other applications that are in the mesh. So in particular, what I would like to do now is to inform my clients and also my gateways that when they want to reach any application, they should not use the Kubernetes naming, the default Kubernetes naming, but they can use some sort of virtual domain naming. And to do that, that's fully customizable. So first thing to think about is to determine if you have some critical applications like those one, A, B, C, D, that are deployed on several clusters. This is the case here. So what I want to do is to group my applications together. So I have, as you can see, I have app A, B, C, D on each cluster. So what I will do is group them together with what we call a mesh multi-zone service. If I head over to the Kong mesh GUI and click the default mesh, I will find the list of services that exist in my mesh across the 2 clusters or 2 zones. As you can see, app A exists on cluster 1, cluster 2, same story for B, C, D, right? But what I want to do is to group them under mesh multi-zone services, which is a specific CRD that comes with Kong mesh or Kuma. And in this case, I will group them together depending on the name of the mesh service. I have already done that. So now if I click this mesh multi-zone service button, I can find my 4 mesh multi-zone service with their own names. I don't have much details there, but if I click one of them, what I can see is they are assigned a particular host name. In this case, the host name is the name of the application.ha.kong.corp, which is something that I have defined, because you can define the domain name you want the way you want, right? So I use the Go template, like display name, which is the name of my mesh service, with this suffix, right? So now all my critical services are available with this virtual domain name. I can also find those from from my cluster. So if I do list the mesh multi-zone services, as you can see, I will see the host name that is generated for each of them. That's the end of the parentheses for mesh multi-zone service. And now let's get back to the demo with different scenarios of failover. The first scenario I want to explain is maybe this one. So in this case, let's say this application A is not anymore available. Let's say it's scaled down. And there are different ways to simulate an outage, but in this case, I will just scale down application A. And now if I try to reach this application A from gateway 1 with its path, my expectation is that since the Kong gateway is part of the mesh, then the mesh is smart enough to route the request not to the local application A upstream service, but to the other instance of application A that is running on cluster 2. So, which is what's happening. You can see the reply comes from application A on cluster 2. I can simulate the same just from my client 1 for east-west traffic. So client 1 again is running on cluster 1, and again the mesh is taking over the routing and sending the request to application A on cluster 2. That's great, but scaling down is not always the best way to demonstrate failures. So what I will do now is to simulate 500s that would be returned by application A in cluster 1. So to do that, I will use what we call generical chaos engineering, and I will tell to application A to start injecting faults, right? This is what you can do with a platform like Kong Mesh. So I'm selecting this application A on cluster 1, and for all the requests that come from client 1 or from the Kong gateway, I will send 500s 100% of the time. So let's apply the policy, right? Now, if I hit the gateway 1 on cluster 1 and app A, I'll get an error, right? Because that's the default behavior. And I will also get an error if I start from client 1, again on cluster 1, and I run a similar curl command. Let me try it, and as you can see, the fault filter is injecting 500, right? That's not really nice. That's not what we want from the mesh. So to work around that, there are different ways. You can either implement what we call active health checks or passive health checks. The goal is to inform the mesh of when an upstream service is not healthy. So there are two ways of doing that. In this case, I will use the circuit breaker policy so that whenever I'm hitting this mesh multi-zone service and it returns 2 consecutive failures or error codes, then the mesh will know that this service is not healthy. So I will just apply this circuit breaker policy. Now, if I try to hit that same application from the gateway, I have 2 errors, 2 consecutive errors, and the third time, the mesh is now aware that application A on cluster 1 was not healthy. So it's now routing the request to application A on the secondary cluster, which is what we want. Let's do the same test from the cluster, from client 1, which is in the cluster. So again, first time fault filter, second time fault filter, which is injecting errors, and third time the mesh is taking over the routing to application A on cluster 2. So that works for both north-south and east-west. Now, if you don't want to see these 2 consecutive errors, we can just use the mesh retry policy. In this case, I'm telling the mesh, okay, whenever you see a 500 error, just retry 3 times. So this way, hopefully, we will not see any more errors, right? So let's apply the policy. And now again, if I start hitting the gateway, not yet deployed, I guess. Yeah, only one error, now working all the time. And same test from my client in cluster 1. I'm hitting application A, and I'm directly redirected to application A on cluster 2. That's great. So that's thanks to the combination of passive health checks and the retry policy. Let me delete these policies, and now we will carry on with additional testing. So the next test in this demo is to kill the zonal control plane of the mesh that runs in cluster 1 and see if there is anything wrong going on. So let's kill it. Okay, it's actually scaled down, and now let me check if I can still consume my applications going through the gateway. Yeah, I can still consume application A going through gateway 1, and again from client 1 running on cluster 1, I can also continue using my services. Let me revert that, and then let's go to the last test, where I'll kill the global control plane that is running on another cluster, just to check if anything would go wrong if the global control plane is down. Just to say before that, when the zonal control plane is down, the impact is that if you have locally generated or originated mesh policies, obviously they will not be synchronized up to the global control plane. Also, if there are new services that are created in the second cluster, they will be discovered by the zonal control plane, they will be surfaced in the global control plane, but of course they won't be propagated to this zonal control plane, which is offline. So that's the impact. Now for this scenario where the global control plane, it's a bit similar. Obviously, all the new services that are created here or there, they won't be propagated to other clusters, but you can still apply local policies using your zonal control plane. So let me demonstrate that. I will stop the global control plane and just check if my data path is still okay. A bit slow, and the reason is because I have a lot of applications deployed. And same story, I will just give it a try from the client in cluster 1, and it's working okay. Again, if the global control plane is not available, the global service discovery capability is off, right? And of course, you cannot access the global the GUI of the global control plane. Let me revert that and see if everything works again, but obviously there are no reasons. Okay, it's already there and back and running. Thank you for watching.